on the recent development in control, automation, and power engineering. My name is Bihan Ravi Shankar, and I will be your host today. As with all our conferences, we're hoping to create a spirited debate, a comprehensive discussion on the various topics in the doc today. So without further ado, it is my pleasure to introduce to you Dr. Vinod Yadav and Dr. Pratima Walde. Dr. Vinod Kumar Yadav is currently working as a professor in the Electrical Engineering Department at Delhi Technical University. Dr. Yadav has received his BTech degree in Electrical Engineering from the Institute of Engineering and Technology in Bareilly, India. MTech degree in Power System Engineering from the National Institute of Technology, Jamshedpur. And PhD degree in Power Systems Engineering from Indian Institute of Technology, Roorkee. Since 2011, he is associated with various technical universities involved in teaching electrical engineering. Dr. Yadav has received the Commendable Research Award from DTU 3 times in 2020, 2021, and 2022, and also received the Premier Research Award from DTU in 2022. Dr. Yadav received the Best Teacher Award from National Education Association, Uttar Pradesh on October 1st, 2016, and also received the Best Paper Awards from ICEEE 2020, NPTI Faridabad, and PyCon 2023 AMU Aligarh. He is a senior member of IEEE USA and a member of the International Associations of Engineers. Dr. Yadav has guided 7 PhD scholars and 30 MTech students. Professor Yadav has delivered many guest lectures in NITs and reputed government universities in more than 50 international reputed conferences. He has published more than 150 reputed papers in journals and conferences. His research includes renewable energy, power systems and planning, and distributed generation and smart grid. We also have with us today Dr. Pratima Walde, currently working with Sharda University as professor and head of the Department of Electrical Engineering. She has received her BE in Electrical Engineering from Government Engineering College, Jabalpur, MTech from MIT Gwalior, and PhD degree from IIT BHU. In 2022, she also received her postdoc from IIT BHU. From January 2003 to April 2008, she worked as a senior research fellow in the Department of Electrical Engineering at IIT BHU. Her research interests include optimization algorithms and machine learning techniques for power systems, IoT applications, renewable energy, deregulation, and AI applications in the power system. Thank you so much for being here with us, sir. And with your permission, I'd now like to ask for permission to start the actual session. Yes, thank you. So the first paper today on the doc is paper ID 148, encoding data using Slayer exciter circuits with simultaneous power and information transmission. And the presenter today will be Ishan Yadav. Please give me a moment, I'll just open your presentation. You have to execute this within 8 minutes and do it for yes. Sure, I'll try my best. Shall I start? Greetings, members of the chair and everyone present here. I am Ishan Yadav, a fresh graduate from Delhi Technological University. I pursued a major in electrical engineering and a minor in computer science. And today I'll be presenting my topic, encoding data using Slayer exciter circuits with simultaneous power and information transmission. Sure. Now, a Slayer exciter circuit essentially is an air-core transformer which steps up a very low DC voltage to a very high AC voltage. It is to be noted that it is supposed to be air-core transformer and cannot be ferrous or iron-based transformer because the magnitude of frequency we are dealing with will be very high and can cause eddy currents to be induced within metallic structures. Now, this creates
an electromagnetic field around the coil that is capable of lighting up fluorescent and neon bulbs around it. Now, this project aims to use this apparatus for the transmission of information as well as power. We make use of modulation to convert our sinusoidal waves into data that we require. Apart from that, finally, it will pave way for my concluding it with how I will use it into a lifetime apparatus. The literature review spanned across mainly concentrating on Tesla coils, Slayer exciter circuits, as well as wireless transfer of energy as well as information. A key paper I would like to mention was in the Brazilian Applied Sciences Review, which used Tesla coils and its generated plasma to transmit auditory signals and using it as sound waves. The proposed model seems to be very simple. My entire build is split in two. I have a Slayer exciter circuit which is attached with a modulating circuit. The Slayer exciter circuit is simple with air core transformers and a simple a transistor, a BJT. It is essential to use heat sinks in it. Apart from that, the modulating circuit uses a MOSFET to envelop the sinusoidal waves with digital on-off key. The proposed model build. Okay, so the entire build spans with three main components. There is the coils part, which has dimensions of 20 gauge wires are used in 320 turns. Apart from that, we have exciter transistors. The exciter transistor, in fact, it is only a single one. It is a BJT, a TIP31C due to its low leakage current, and I use it as a switch. And using a resonance condition, I create sinusoidal waves. Apart from that, lastly, I have the switching transistors. So there is the MOSFET, the IRZ44N, that serves as the key to the modulating circuit. But since the entire circuit works on 5 volts, I step it up with a PNP transistor that allows more than 3.3 volts to be supplied to my circuit. The proposed model. So now comes the modulation. The thus generated carrier EM wave is modulated using amplitude shift keying. Considering the media can be noisy, error handling techniques were used to maintain the correctness of data. Hamming 7 port was employed for the same, as well as so it just converts a 4-bit stream of data into 7 bits. This allows me to transfer the entire data signal through a very noisy media and yet maintain its parity. Sure. Shall I continue?
Which one of these is your slide?
Mine would be template.
This one? Screen 2. This is the starting slide that is on.
Okay, now since it was established that we have a noisy media, I allowed my parity bits to be appended to my normal data that will allow me to handle single bit errors on the receiving end. The program and logic. So I input a stream of 4-digit numbers in binary. I allow my Python program to append the parity bits necessary within the Hamming 7-4 encoding scheme. I then use it to drive my modulating circuit. The modulating circuit essentially envelopes the square wave onto the sinusoidal wave we have, and then allows me to transmit both power as well as information simultaneously through my thus built coil. So the result methodology. Now we know that incandescent bulbs have mercury atoms that can be excited with EM radiations. They provide a very nice way for me to harness this energy. I also simultaneously use an oscilloscope, a DSO 138, which allows me to basically measure the pulse width as well as the waveform. A single 1 bit on the modulator would translate to a bulb getting switched on, and a 0 bit will be switching off the bulb. So the result analysis was simple. I was able to create a sinusoidal wave on my DSO using the said apparatus. And this was the on-off keying sample of the data. I employed Hamming 7.4, and hence you can see the 1 bit would switch on the sinusoidal wave and the 0 key would switch it back off. This allowed me to transmit digital data using an analog system. Conclusion. Okay. So the slave excited circuit facilitates simultaneous wireless power and data transmission through innovative modulation techniques. Amplitude shift keying, ASK, and Hamming 7.4 encoding are employed to enhance data transmission reliability in the presence of noise. Utilizing the persistence of vision effect, that means that we have 116. If I play 16 frames in 1 second, the human eye will not be able to distinguish whether they are separate frames. And hence, utilizing the persistence of vision effect, rapid data transmission through light modulation becomes imperceptible to the human eye. Household lamps are transformed into Wi-Fi devices, enabling efficient wireless power transfer and secure data communication. Wi-Fi technology offers advantages including higher data rates and improved security, making it a promising solution for various applications. The integrations opens the door to expanded functionalities for household devices, enhancing wireless communication in residential and commercial environments. That will be it. These will be my references. My references, again, I can tell you, they span across Tesla coils, they span across modulating plasma to achieve sound waves, and they span across Wi-Fi devices. Thank you.
Any question?
Okay, so I inputted 9 volts of input supply. This allowed me to get around 550 volts on the output with very low current. This was able to generate sparks with parasitic capacitance towards the earth, and I was able to generate plasma from the same.
Here you are using one transistor.
Yes.
What is the role of transistor? Or switching or other?
So I used a total of 3 transistors, one for the slave exciter circuits and the second one for the modulating circuit. The first one is the TIP31C BJT, which is an NPN transistor. It allows me to use resonance conditions to switch it on and off very rapidly in megahertz level of frequency. The second transistor I have would be a MOSFET IRS. Okay, sir, if it's possible, can I present my diagram again? You see the circuits, the above circuit. There is a below modulating circuit and the above circuit that happens to be the slave exciter circuit. The TIP31C, when provided a small current to the base, it allows conduction of current and it will induce a current in the secondary coil as well. The secondary coil provides a very large negative value to the base of the transistor again. To the base of the transistor, now there is a negative value. That means the flow of current stops. This shuts off the transistor, puts it into switch off mode. Again, through Lenz's law, a mutual induction is achieved on the primary again. This again puts a positive value on the base of the transistor, positive current value. Again, we can see the current flows through the transistor again. This on-off switching creates a very rapid sinusoidal wave that allows the conduction through the space check.
Yeah. You are using NPN transistor.
Yes.
One terminal is connected to the transformer.
Yes.
Another terminal is connected to switching circuit.
Yes.
What is the role of the transformer? But it is you are getting the primary pulse from the transformer and secondary are moving.
Yes. But it is connected to the ground through parasitic capacitance.
So why you are to the transistor to the
Okay.
what is the rule?
What is the rule? I'll tell you. The current flows through P and Q. Right? First.
मेरा एक आप वहां से कनेक्ट कर रहे हो और फिटिंग उससे क्या इफेक्ट क्या पल्स दे रहे हो?
Okay. No. So जब प्राइमरी के थ्रू हमारा करंट फ्लो करेगा, the secondary gets induced a value of current, right? The secondary का जो connected है to the base of the transistor, you can see that will provide a very high negative value.
So you are getting the negative value from the secondary side.
Yes, exactly. A very high negative value around, and that will actually stop the current flow to the base of the transistor. The moment it is stopped, the current stops from the primary as well. Okay, so Lenge's law will say that there is a positive and a negative, a positive and a negative on the P and Q terminals. This will be reversed on the secondary, and hence I will be getting the negative value due to the mutual inductance of the apparatus. Very high negative.
If of ground field, how you are saying it is you are getting the negative because both the dot convention is same. Because dot convention
Oh, okay. I think that I might have missed the dot convention. That was not really the idea behind it. That was the only closest thing I could have to an air code transformer on the ID that I was using to build the circuit. I mean, the software I was using provided me with this. The dot is not really my.
conflict
Am I?
in the secondary side because dot convention is same and the R is connected to the ground. You say that because R and S is connected to the key.
Sir, I'm pretty sure I was getting a very high minus 22 volts, I would say, on the
Minus
22 volts.
from the English
Exactly. At an instant, it was calculated to be around minus 22 volts, even though I was supplying 9 volts to it. That's why it was a very high negative value. And that would stop the current at the base of the transistor, allowing it to stop. And so mutual inductance, again, it would lose its magnetic field. Sure. Mm-hmm.
So what is the band range to provide the pulse from the transistor? How you will control your range?
How I will, sir,
कैसे मतलब मान लो आउटपुट नेगेटिव वैल्यू ज्यादा हो तो आप कंट्रोल कैसे करोगे?
the only range that I did compute was the distance as far as my incandescent bulbs light ups from the transistor, from the coils that I had. That was supposed to be 20 centimeter. That was the maximum data I had. If that is the question you are asking.
Switching function
So switching circuit. Okay, I have the switching circuit on the next slide. So there is an IRS Z44N MOSFET, and yes, this is the switching circuit. This is the modulating switching circuit. There are two switches I have. This lets me envelope a DC voltage, a digital signal onto an analog signal through on a field called amplitude shift key. And since the Raspberry Pi microcontroller I was using only provides 3.3 volts, to step it up, I used a PNP transistor to allow me to get 5 volts. Is that it? Thank you so much. I am Ishan Yadav. Date.
just passed out from the
DT.
last year.
This year in June.
I think
Thanks so much.
Shall I continue with the next paper? Okay, thank you. So the next paper is paper ID number 293, PLC SCADA-based automation system for remote and sensitive areas by Gaurav Kaushal, Ankit Gupta, and Lokesh. 3 members? That's it, okay. Yes, sir. Have you emailed the paper? There was an email on the group. Have you emailed the paper?
in between, please for the next.
Try, you just email it and come to the office. Yes, sir. So in the meantime, we'll bring on paper ID 302, an intelligent approach to assessing the effects of orientation and climatic zones on any energy consumption of a residential building by Arti and Timid Sirohi. Are they here today? Ashish Kaushik and Timid Sirohi. Seeing that they're not here currently. No, they're not here. The 293 is here, but they have to send their paper still. 302 is not here currently. Yes, sir. So we move on to 304. Investigating key EA with restarts for solving IEEE CEC 2002 benchmark problems. And the presenter today will be Lubna Siddiqui. Okay, have you sent your presentation? 304 conference RDCAP. Yes. This is yours? Okay, and just a second. PowerPoint slideshow screen.
Good morning, everyone. My name is Lubna Siddiqui. Quantum computing is ushering in a new era of artificial intelligence by exponentially increasing the power of computing. Quantum evolutionary algorithms are at the forefront of this transformation, harnessing quantum computing's potential to improve problem solving in unprecedented ways. To provide a concise overview of our work, we have evaluated a quantum-inspired evolutionary algorithm with different restart strategies. The algorithm, along with the proposed greedy local restart algorithm, is tested against the IEEE CC benchmark functions. The results indicate that inclusion of restart tactics improves the performance of an algorithm. These are the topics to be discussed in the next few slides. Evolutionary algorithms are optimization techniques inspired by natural selection, using operators to evolve and improve solutions over time. While they have proven to be effective in a wide range of applications, they also have certain drawbacks like premature convergence and lack of diversity. These limitations can be mitigated by using the principles of quantum mechanics, thus giving rise to a new class of optimization techniques called quantum-inspired evolutionary algorithms. These QIEA help in navigating challenging landscapes more effectively to discover improved solutions. Though efficient, QIEAs also suffer from certain limitations, such as being stuck in a local optimum. Now, these can be effectively tackled with an elegant solution of triggering restarts in an algorithm. In QIEA, qubits are the foundational elements for representing potential solutions. These qubits, acting as the smallest unit of information storage, can be in the states ket1, ket0, or a superposition of both, defined by complex numbers alpha and beta. QIEA employs the string of n qubits to represent an individual referred to as a chromosome. This chromosome serves as a candidate solution within the QIEA. Now, this is the algorithm of quantum-inspired evolutionary algorithm. The algorithm begins with initializing the population with random qubit chromosomes. Each chromosome in the population denotes a possible solution for the objective function. The qubit string is first collapsed into a binary value and then to real coded parameters. These real parameters are then evaluated against the benchmark functions. If the known minima is reached, then the algorithm terminates, else a rotation gate is applied to create the next generation of offsprings. These new qubit individuals go back into the loop where they are evaluated against the benchmark functions. This loop continues until the optimal is reached or maximum function evaluations are executed. Now, the rotation gate is the key component used to update the state of a qubit individual. The update given by this equation involves a rotation angle theta for each qubit determined by its sign, either towards 0 state or the 1 state. In Q&A, when B represents the best solution found so far, the quantum rotation gate is employed to emphasize the search direction towards B. Now, this is a 2D representation of how rotation works on a qubit. The sign of alpha and beta will decide the direction of rotation. So if the best bit is ket 1 and the current bit is ket 0 and the sign of alpha and beta is positive, then a positive angle of rotation is applied to ket 0. If the sign of alpha and beta is negative, then a negative angle of rotation is applied. Also, as shown in the lookup tables, the angle of rotation will depend on the fitness of the current bit and the fitness of the best bit as well. Now, introducing restarts in the algorithm. Restarts are introduced whenever the fitness of an algorithm stagnates or does not improve over time. They could be an effective solution to improve the algorithm and move it out of the local optimum. There are two popularly known methods known as the global restart or local restarts. Let's explore them. So the global restart, the algorithm for introducing a global restart is similar to that of a basic QIEA, except for the highlighted portions. Here we check if the fitness has improved or not. If the fitness has not improved, then a restart is initiated and all the candidate solutions are wiped clean and resetted to random values again. Whereas in the case of local restart strategy, a subset of best solutions is saved. Yes, but the rotation and is applied on the qubit itself. Real values, we are converting it into real values because we have to test it on the benchmark functions. But all the operations, the operators are applied on the qubit values only. So when you're wiping clean all the candidate solutions, means you're wiping clean the qubits. Weight. So my objective functions are IEEE CEC 2002 benchmark functions, which are 12 functions, which are given in the technical report of IEEE CEC. So we are initializing qubit chromosomes. So those are random values. Then we're converting them into binary. So where we on on software on a system, as in
software. So they have collected the data from
the functions are IEEE CEC 2022 functions, and what we are doing is we're using those objective function values and trying to solve them using this algorithm, which is software based. But there is no data per se. Right. So the known minimum is given in the technical report that these objective function values will have this known minimum. So the first objective function value, it is already given, it's there in the appendix also if you want to see. All right. So the objective functions are 12 objective functions. And yes, they are on IEEE CEC benchmark functions.
Here you are, which one you are considering? Only you are minimizing the error.
Right.
And maximizing the output.
Minimizing the error, right. That is my output.
The one
12. So we have implemented
12, one at
a time, of course. So these are the 12 functions. Maybe later. All right. So these are the 12 functions.
You have to give me one.
Yeah.
I think some of these.
There are 12 objective functions or different
Evaluations.
different criteria of
So 12 objective
or
functions,
different constraints.
different constraints. Right. So they were all tested with this algorithm, one at a time, one trial at a time.
This is it. Have you removed? Have you taken off the
This one.
presentation?
Yeah, this.
Right.
Yeah.
Good.
So these are the 12 objective functions.
Don't put it in the presentation.
Right?
So you can show the objective function.
Functions. Okay.
Objective function represents
Right. So these are the different objective functions. These are all given in the technical report itself. These are the different landscapes and how these functions look. So there are 12 functions in all. First 5 functions and then 3 hybrid functions along with 4 composition functions. No, sir, this is already present in the technical report of IEEE CC benchmark functions. Yes, I'll tell you. So here, so we were talking about QIEA. So, sir, I have applied a simple restart. Proposed a simple really local restart algorithm, which will be tried on these benchmark functions, and we will compare the results of a no restart strategy.
You are just exactly taking some objective from my side.
Absolutely.
What is your role?
So, sir, I have created an algorithm. I have proposed an algorithm where I have introduced.
Depends on according to the objective function.
So, sir, these objective functions are the benchmark functions, means that they are used to evaluate the performance of any new algorithm. So to know that if any algorithm is worthy algorithm or not, we try them on these benchmark functions, and if they serve well or if they're doing well, if the algorithm is doing well on these benchmark functions, means that this algorithm can serve most of the real world problems.
So आपका objective function क्या है?
मेरा objective function is right.
ठीक है अपना
हाँ जी. तो सर ये global restart है, and this is how local restart works. Now this is my proposed algorithm. So now this is the proposed really local restart algorithm. So here what we've done is that we've checked whether the fitness has improved in the last few generations or not. And if it has not improved, then we save a subset of the best 3 solutions and then reset the rest of the population. So this is variant A. So we have proposed 2 variants. The first variant where we're saving top 3 solutions, and the next variant B, where we're saving only the best 1 solution and resetting the rest of the population. And this algorithm was tested on these IEEE CC benchmark functions to know whether this algorithm is best suited for real life applications or not. So these are the testing parameters where we have 12 minimization problems and the dimensions is 10. Okay. It's on the you can fix it. I don't know. So these are the results.
To this.
So here are the outcomes of our experimental assessment. We've compared the performance of QIEA with no restart algorithm and various restart strategies. Notably, the global restart strategy yielded improved results in 3 out of 12 instances, while our proposed greedy local restart algorithm outperformed in 9 out of 12 cases within the benchmark suite. Now, these findings strongly support the superiority of this algorithm. So as we can see, the QIA algorithm starts with the black line, quickly encounters a local optima, and hindering further progress of this QIEA with no restart algorithm. As we introduce a restart, a notable improvement in results can be seen. The global restart algorithm with the blue line delivers some improvements, but faces another local optima and is not able to escape that. But the greedy local restart variants A and B exhibit remarkable performance, with variant B delivering the most promising results and closest to the minima. So this variant B and variant A. So variant B is the closest. The yellow and the red lines. The best being variant B. So this could be attributed to its ability to strike a balance between knowing the best solution so far and introducing a set of fresh solutions with each restart. This approach allows the algorithm to explore new solutions while still benefiting from the lessons learned in the past. So to conclude these slides, we wanted to investigate the impact of including restart strategies in the convergence and optimization of QIEA. We explored 2 restart methods, the global restart and local restart. While global restart was effective in finding better solutions with fresh starts and increased diversity, it occasionally got trapped in less than ideal results. Conversely, in local restart, the proposed greedy local restart outperformed in 9 out of 12 times, achieving results very close to the minima. This success can be credited to its unique ability to learn from past generations while exploring new solution spaces. Thank you. Yes.
Question. Yeah, next. Yeah. Next.
So the next paper we'll be bringing on is paper number 293, paper ID 293, PLC and SCADA-based automation for remote and sensitive areas. And the presenters today will be Gaurav Kaushal, Ankit Gupta, and Lokesh. 3 members. Okay, no problem. Would you just tell me? Okay, so you email the PPT. There is no attachment. It's an attachment. Oh, there is. Oh, there is. This is yours. And this is not yours. This one is yours. And go ahead.
Morning, everyone. My name is Gaurav Kaushal. I'm from JSS Academy of Technical Education, Noida, Department of Electrical Engineering. Well, I was a student there. Now I am a pass out student. So my title of my paper is PLC SCADA based automation system for remote and sensitive areas. So we have used a PLC, and my name is Gaurav Kaushal.
You are the only student.
Yes, my friend Ankit is also there. He is also called that. Yeah, if any questions, yeah, I'm only. So the modern facilities can be improved in terms of productivity, efficiency, and safety using automation techniques. The automation technique we are using is PLC SCADA, which is very reliable, and we can use many different kinds of PLC. We have used GIC PLC, which is a 8 input and 4 output PLC. These are the related works which we have used in our paper. Badir et al. Research addresses the challenges related to data privacy, device authentication, secure communication, and the smart homes with data integration. Mukawar Sawat emphasize development in of energy efficient smart homes by addressing these task scheduling challenges. Zhang's doctoral dissertation explores the concept of smart houses and their potential impact on future housing. It serves a foundational work for understanding the long-term implications of integration automation technologies into residential environment. So what we are doing is automation of lights, fans, and fire alarm and security alarm. This is the proposed work. We are giving DC power supply to our output devices, which will be light, alarm, and fan. So these will be on and off using a relay. The signal will be given to the relay from the PLC output. And we are using a laptop or any programmable device to program the ladder logic, which is a bit logic, which uses NO and NC for programming different types of logic, which include counters and timers. We have used this is our logic which is being used in the PLC. So if a signal from temperature sensor and PIR sensor is sent to the PLC. So I1 is our temperature sensor, which will give a digital signal to the PLC, and PIR sensor is our analog sensor, which will give an analog signal. If a voltage is the signal or voltage signal is more than 5 volts, then the PLC will trigger this logic. Yes, and the fan will be turned on. Similar logic of lighting is also there. So we can conserve energy using this logic. The fan will automatically turn off after 5 minutes if no one is there in the. Yes, saving electricity and security integration in PLC. We are also using this security alarm. We have also boundary alarm. Fire and security alarm both are in the system. We are doing automation of 4 things. First is fan and lighting and burglar alarm. Yes, our objective is electricity saving and security.
And we have set up school suggesting some model.
Yes.
What is the cost?
Cost is around, sir, PLC which we have used is costing around 4,500, and the sensors are costing around 200 to 300 per sensors.
What is the total cost you there?
If we have to automate this room, so we will require around 6 to 7,000.
6 to 7,000.
Yes.
So what is there? Say if we are suppose we are
Yes.
installing my residence house. So how many years we will save by
Cost will be recovered. You are asking.
से कितना मतलब आप
So, this can last. This PLC can last up to 5 years. So, and the costing of electricity.
मेरे को तो कोई नॉबिलिटी नहीं है बट ये नॉबिलिटी ऑफ
Novelty is, sir, we are using a PLC to automation in home automation. Yes.
इस तरह की मॉडल भी है तो आपका
सर बेसिकली नॉवेल्टी हमारी ये है कि आवर फाइनल प्रोजेक्ट वाज दैट जो प्रोटोटाइप मॉडल बनाया था उस समय हमने, तो उस प्रोटोटाइप मॉडल में ये 4 चीज हमने दिखाए थे, क्योंकि बेसिकली जो सिक्योरिटी अलार्म की कॉस्ट थी हमारा और भी प्रोटोटाइप उसमें है
सिक्योरिटी क्या
यस सर सिक्योरिटी सर बेसिकली कंसिस्ट ऑफ फायर अलार्म्स एंड ग्लास ब्रेक अलार्म व्हिच विल बी used as a burglar alarm as well. Glass breaking alarm. It will be consist of sensor 4 sensors and glass breaking sensor. So it will get
ये क्लास
yes
तो यू आर कहां पे लगा रहे हैं
सर वो प्रोटोटाइप में हमने शो नहीं करा था, लेकिन
We have tested this
We have
in a simulated environment in our college. We were allotted a room and we implemented the system there. So,
इस क्लास को कैसे आप अलार्म कहां लगाओगे कैसे
Yes.
पता है
yes
इससे क्या है आप कैसे
so basically sensors होते हैं एक we have a sensor piezoelectric sensor. Piezoelectric sensor जब फोर्स उस पे पड़ती है तो उस फोर्स को वो कन्वर्ट करता है इलेक्ट्रिकल एनर्जी में, उससे हम एक बिट लॉजिक लेंगे, उससे एक बिट लेंगे और उससे हम एक अलार्म को सेंस कराएंगे. तो अगर ग्लास के ऊपर बाहर से स्टोन पड़ता है या इनकेस ग्लास शेड होती है तो उस केस में हमें वहां से इनपुट मिल जाएगा, एक डिजिटल इनपुट मिलेगा और उसके थ्रू हम अलार्म को आउटपुट दे देंगे.
this is the ladder logic which is uploaded in the PLC. So these represent and or all of them. This is the circuit diagram of our system. So Q1, Q2, Q3 is our outputs. Will trigger the relay is integrated in the PLC. So, and this this is the SCADA layout. If we want to visually represent our system on our computer, we can connect the PLC using RS485 Ethernet or different. Yes.
एक घर के लिए कितना पावर कंज्यूम करता है तो ये कंज्यूम का मंथली कंज्यूम करेंगे पर्टिकुलर एवरेज तो कितना सेविंग होगी ये बता सकते
सर टोटल सेविंग अबाउट 20% से अबव.
20%
अगर एज अ जनरल हाउस होल्ड देखते हैं, लेट इट बी ए मिडिल क्लास हाउस, तो अगर फैमिली अगर एनर्जी कंजर्व करना चाहते हैं तो सर और भी बहुत तरीके हैं. अगर पीएलसी को हम देखते हुए करते हैं, अगर सेंसर्स के थ्रू या बाकी चीजों के थ्रू, ऐसे प्रैक्टिकल बेस अप्रोच तो नहीं थी हमारी उस काम को करने के लिए, लेकिन टोटली हमारा ये मोटिव है. यस सर यस सर
हो जाए मान लो हम एकदम बिल्कुल नए कमरे से बाहर निकले बंद करते it will depends
ये सर डिपेंड करता है.
सर एनर्जी तो सेव होगी, मतलब
चलो
गलती तो हो ही जाती है कि रह जाता है ऑन रह जाता है, ये ऑटोमेटिकली ऑफ करने के लिए.
मोस्टली सर टास्क शेड्यूलिंग के लिए बेसिकली.
System collected data and interactive with physical world using sensor.
यस सर कैलकुलेशन साइड.
see that changing
जो ऊपर ये नहीं
सर कंक्लूजन है वो थोड़ी सा ऊपर है.
So the system demonstrated quick response time and kept stability under a variety of circumstances. Overall, the system provides dependable and effective monitoring, controlling capabilities for remote and sensitive locations.
ठीक है.
We are
Next, we have paper ID 302, an intelligent approach to assessing the effects of orientation and climatic zones on energy consumption of a residential building. And the presenter today will be Ashish Kaushik.
काम चला. आप सही हो गए. तो किसी को क्या
Operational problem with the content. Correctly prepared. हाँ, तीन थोड़ा कुछ फॉर्मेटिंग में चेंज है. ये तुम्हारा था क्या? Okay.
This one is mine. It's
हाँ, ठीक.
currently present on the paper ID number 30.
Yes.
You are from which department?
So civil. Yes. So may I start? So may I start?
You are basically from civil.
Yes, I just passed out this year. 2023. So it's related to energy conservation. Yeah. For a residential building. May I start? Okay. So good morning, sir. Good morning, ma'am. My name is Ashish Kaushik. Today I'm here to present. My research paper, an intelligent approach to assessing the effect of orientation and climatic zones on energy consumption of a residential building. Now, these are the contents that I will be discussing about. First, I will give a brief introduction. Then I will discuss about the problem statement that we identified before starting the research. The next one is the objective. I will also state about the objective of this research paper. Next is we have basically used certain BIM tools, building information modeling tools. So I will give a brief introduction about the tools that we have used. Next is the building details. So as next slide. Okay. So the building life cycle defines the entire life of a building from designing through conception, occupancy, and on the eventual demolition. Now, this creates a need for long-term energy efficient designs to be present in all buildings. Building information modeling, that is also known as BIM, provides us with a proper sustainable design because it helps us to iteratively test the building design and also improve the energy consumption. So basically, it helps us in energy conservation of the building. Now, using BIM, that is building information model. Sorry. Okay. So the problem statement that we identified before starting the research is that energy analysis is becoming an important factor to be considered in the AEC industry these days because of the worsening global warming and energy crisis.
the energy analysis needs to be amalgamated into the designing phase, that is before we start the construction of the building. So we need to rectify it over there itself. Now, forecasting the energy usage of the building and using a suitable energy consuming method and designing the construction is the need of the hour. So the main objective of the project is to determine the energy consumption of the building and to analyze how the building orientation and different climatic zones different climatic zones affect the energy consumption of the building. So there are two tools that we have used in this research. The first one is Revit. So Revit is an it is one of the most majorly used BIM tool that is used for developing and simulating the buildings and associated systems in the AC, architecture, engineering, and construction sector for designing and modeling buildings. Now, in today's world, architects and engineers they use Revit a lot. So this is a software that basically builds a 3D model of the building. And the next software that we used is GPS, Green Building Studio. So it is a cloud-based energy analysis tool that helps to evaluate the energy performance of the building designs. GPS basically uses simulation and modeling tools to predict the energy consumption of the building, and it also gathers the information regarding the environment and temperature. Yes, sir. So this is basically the building that we choose is an existing building in Mumbai, Worli, and it is an two basement, one ground floor, 8 parking floors, and at the end 10 residential floor building. So basically it is an 18 floor building, which is actually situated in Worli, Mumbai. So the prerequisite that we needed for the research is first we needed the building geometry, building drawings, and configuration of the space, building orientation, the building's functional uses, and the HVAC system that is used in the building. So which basically determines the energy consumption of the building. Now the current utility rates also is required to figure out the energy consumption of the building. So the procedure that we followed is first we gather information regarding the building and we gather drawings and other considerations of the building. Then so we build a 3D model. We developed a 3D model in Autodesk Revit. And at the end, so what we did is we exported it to GPX format and then imported it to GPS, which is in cloud-based software. Now, GPS will do the task to analyze and execute results regarding the building energy consumption. Based on my research. Energy consumption. Yes, sir. We have. So I will show you. The pictures are not visible actually. I pasted my certain screenshots. So can I show it in my laptop? So these slides contain the results. Like so all the next slides contains a certain graphs so that I can explain. So we have some missing. So all these slides contain graphs and screenshots of the results. So I have this chapter over here. I will show you. Please show you. We are in between for the next one. So this is the way of
Next, we will have paper ID 520, which is Green Energy Solutions, Challenges, and a Future Roadmap to Sustainable Development. The presenters today will be Anisha Hazarika and Devran Singh.
We are talking that building. So you are saying
Okay, with the title.
Green energy solution.
नहीं, title different करो.
524 beam.
अच्छा. आपने भेजा था?
दो बार भेजा था, forwarded बना.
अच्छा.
Slide is visible there or not?
But just answer, open the presentation.
What is your super ID? 535. 1172. It is already downloaded.
520.
It is not downloaded.
Yes.
Okay. Let us download this. It will go in the download.
Yes. Last three I have downloaded on this. So I will move all of the PPTs in that folder after the session.
This is already done, na? No, he discuss it.
So here's the 520.
Let me go to the particular folder. Where is the folder? And let us close the file.
No need. Yes. This is it. Just give me one moment. I'll screen share.
Depends on the reliability of the building. डिटेल्स से थोड़ी माने थे यार अब ये बताओ देखो एनर्जी मतलब जानते हो तो जो कहना चाह रहे हैं वो नहीं है एनर्जी कंजम्पशन मतलब बिजली का कंजम्पशन होता है तो बिजली को कैसे इसको जब पावर नहीं हो पर
Just give me one.
आपको मटेरियल ग्रो करें मटेरियल There's a change in orientation to building also. So we can change the distribution. One piece of the river different planting. The first one is Chennai, which is an ordered English planting. Second one is Jaipur, which is ordered planting. The third one is bigger component, which is Chandigarh. We can't take in Chandigarh. And the fourth one is ordered. So as you can see. So each one shows the total energy cost, like the electricity bill, which is coming out of 2040 and in all the 4 billion, the cost is 50. Seeing this, building we have the number of people who building the building number of building and getting the energy cost is very and after it is like you can need more energy there. Then to get very what is it? So this is the so in the designing itself you get we are also this climate to material is for दोनों को जब शो करा है ये सो रही है ये हो रही है शिफ्ट करो तो कर दो कि आप शायद ये हो जाए पता नहीं बनी नहीं चंडीगढ़ चेन्नई अगर कंपेयर किसी भी करते हैं तो ये रिलेशन को शिफ्ट करोगे कैसे कोई ये डेट दोबारा चेंज नहीं क्योंकि वहाँ का साइंस डिपेंड वही तो मैं बोल रहा हूँ अभी आपको बिल्डिंग ठीक है those who are they can go.
Good afternoon, everyone. My name is Anisha Hazarika, and he is David Singh. We are currently pursuing MTech in Environmental Engineering from Department of Civil Engineering, SF MIT Noida. And our paper title is Green Energy Solutions, Challenges, and Future Roadmap in Sustainable Development. This is basically a review paper which focuses on the green energy solutions. This is a table of content. We have introduction, green solutions using green chemistry, major applications, and some case studies, and recommendation, then conclusion. So coming to introduction, we know due to rapid urbanization and industrialization, there is significant rise in population and also the demand for energy needs. So this is in a way creating environmental degradation or pollution. And so as to mitigate that problem, we have introduced green chemistry solution, which focuses on processing of products, and which makes it eco-friendly designing and commercialization workable and economical. It helps in finding the mitigations. So in this particular study, we have taken few case studies related to some industries. For example, we have taken electrical vehicle technologies and eco-bricks as a solution. These are the basic green solutions using green chemistry, and these are the different green chemistry principles, which focuses on the prevention, atomic economy, less hazardous chemical synthesis, design of safer chemicals, then energy efficient design, renewable feedstocks, reduction of derivatives, catalyst, and real-time pollution prevention. These are the major applications of green chemistry which we are currently doing. Like we are using it in the green solvents, we are using in dry cleaning, bleaching agent, pharmaceutical industry, packaging industry, construction materials, renewable industry, etc. So coming to case study number 1, we have electrical vehicle technologies. We know due to rapid significant rise in the CO2 levels, we have now introduced the new electrical vehicle technologies to which reduces the fuel consumption than the normal vehicles we use. But it provides a solution for the environmental upliftment, but it also have some secondary issues. We have pointed out the major secondary issues which degrades the environment, like we have mining problem, and also for the lithium ion, it uses lithium ion batteries. This produces like a huge disposal problem is there, And also there are problems related to charging stations and all. And also, and we think that if we focus on more on the life cycle assessment of the electrical vehicle components and the batteries, then it will be more beneficial. The rest will. Yes, sir. Sir, now-
I'll take over from here, sir. So what basically we have done, there are many case studies which have used green energy, but they're saying that we have found the solution of the problems which is actually happening related to the environment or energy solutions. But they just only saw the primary impact which is happening. They didn't they're like, "Hey, this is a problem. I gave you a solution and it's sorted." It's not. A secondary problem came into that. So what we did, we just summarized what are those secondary impacts. No, this is not where it's stopping. We have just concluded those in secondary impacts that they told is probably not happening. So as she told about electrical vehicle, the second case study, there are so many places where these things are used. We have just taken a few. The second one is the production of biodegradable packaging. So in biodegradable packaging, as the packaging industry is increasing, it's gonna increase the wastage because we can see Amazon packets and all, it's coming plastic. So it is very hard to biodegrade it. Like if it's going into sewer pipe, it's causing problems and all. Instead of that, what they are doing is they introduce the biodegradable packaging. It's going into treatment plants, biodegrading, and the problem of choking and all and other things are sorting out. But they didn't notice that with the increase in demand, it's going to increase its production also. So where it was supposed to help in minimizing that problem, instead of that, the end result of was this, it will release the CO2, H2O or other greenhouse gases. Those gases increase in a huge amount in nature. So now, instead of solving one problem, another problem came into account. Now you can see it's the month of October, it's too heated. Why it is heated? The greenhouse gases, the concentration is so high out in the atmosphere. These are the things. The other example we can take is use of eco bricks. Usually, normal bricks are made of silica, alumina, manganese, and all, which affects a lot. So they introduce eco bricks, but eco bricks are so high cost effective, high energy consumption. So we can't use it on a large scale.
Richard,
Yes, sir. Review paper. Yes.
yes.
Yeah. Just textile industry also we have incorporated. It's the same as packaging industry only, just in textile. So and green solvent as well. So what the recommendations we are giving, every industry what we have studied and seen so far, they are like they focus on one problem, they sorted it out with the help of green energy solution, they ended up in another thing and they ignored it. They didn't go for the secondary problems. So we just said, no, this should not be the solution. What is the point? If one problem you're sorting, creating another problem, make it full recover. No, just completely make it green. So they ignore the secondary impacts and they just so that's what we are saying. In conclusion, the green energy solution can be very sustainable, but some more study and some more research work need to be done. If suppose in some of the industries the waste is producing, the biodegradable waste, if it is sent into some biogas plants, we can create energy. That energy can be used in the same industry, and it's gonna help in the it will be a cycle. Like they are consuming energy, they are producing waste, they are making energy out of it, and they are reusing it. Like it's in that way the environment is going to be more sustainable. That's what we are trying to tell you. This is how they can do. Yes, sir. That only the 4 5. Sorry, ma'am. Electric vehicle, ma'am, that we can say, suppose it's using lithium ion battery. Lithium ion battery needs very heavy metals like cobalt, nickel, and all, which is very, when, suppose they are first of all, disposing is very. We giving what they are giving, like what we are giving. Lithium ion battery, ma'am, they're more like sustainable ways of need to be incorporated. More sustainable in the sense like the problems that we are facing. What is the problem using this energy conserving solution? We are creating other environmental problem. Instead of that, use some other alternatives which will be more.
So, like life cycle assessment from cradle to grave, then it will enhance the quality of the batteries. Like we can prevent which can degrade the environment.
Next, we will have paper ID 517 will be presenting online. So for this case, would the presenter please share their screen and just give us a moment, we'll tell you when to begin. Paper ID 517 is Sustainable Solution for Power Generation using Solar Tree, and the presenter is Anuradha Singh.
Good afternoon, sir.
Good afternoon,
Good afternoon, everyone.
Screen for a moment.
I'll be sharing I have my co-presenter with me, Mr. Rishabh. He will be sharing his screen in a moment.
Okay, no problem.
Rishabh, are you hearing? Rishabh?
Yes, ma'am.
Okay, please share.
Please share your screen.
Yes.
Just a moment, sir.
Okay. Should I start, sir?
Yes, you may begin.
Okay. Okay. Good afternoon, everyone. Myself, Mrs. Anuradha, and my co-presenter, Mr. Rishabh, will be presenting on sustainable solutions for power generation using solar tree. I am from IMT University, Meerut, and Rishabh was a student in this session from Core University, Core College, Roorkee. And we are giving a feasible solution for sustainable power generation using solar tree. Please change the slide. So that is the main work what we have done. That is the generation this presentation of our solar tree, and which will be giving us the sustainable solution for climate change, for emission reduction, and also in a when solar panel is being used as solar tree, it will be reducing the shadow effect also. Now I introduce Mr. Rishabh Kumar to go through the presentation. Rishabh,
Good
please.
afternoon. Good afternoon, everyone. We will start from the details what we are going to be present over here. First of all, we have designed the solar tree. For that, before we have selected the modules, also solar panels and battery, which will going to be for the power generation we will be going to use. In detail, we will start from there. Solar panel operation, that 12 watt we will be using that solar panel, as well as 50 watt each solar panel will be going to use. Almost 500 watt generation will be there around by each panel 50 watts. So 10 solar panel is going to be connected there. And each, if you see the on panel open circuit voltage 11 volt to 21 volt, there is varying because initially we were deciding to establish only 5 panels, but the efficiency and the power consumption was not being up to the mark. So we decided to push our solar panels, and we decided to take 5 more solar panels. So different manufacturers have different specifications. So this is the reason we have taken from different manufacturers. So some have 21 volts, some have 12, some have 12. So this is the reason which is going. Then comes to the battery, that we have used the dimness battery, which is being 12 volt and 150 Ah C10.
Next comes to the design. This I have made by myself. 3D design which is being designed in the Tinkercad software, as well as in initial we have decided to make this schematic diagram as a circuit diagram, just to show how it is going to be work. In furthermore, I will be going to show you how each and everything has been done in detail in MATLAB software, to prove that how we have done the 500 watt power generation. So I will show you one small video that will show how much we have done efforts for to build this project. So shall I show you this video, sir? This is the site work which we have done, and this is the actual project which is in construction work earlier stage. And if I show you the what was the 3D design, this is the 3D design which we have done work in Tinkercad software, and all the dimension which is being present over in this video, as you can see the each and every parameters which we have done work on that. And each and every parameter we have first measure out according to the actual site parameter, because the sunlight which is going to be reflected on the panel at what particular time. So for that we can say time and parameter, we have designed all the length of the bars, and as well as the actual height of the pole. And we have done the angle also, at what angle we have to shift all the poles and each and every solar panel, so that we can get the maximum efficiency of this solar panel. And this is the battery and inverter which is present over the bottom of the solar panel, so that we can get the maximum efficiency and get the backup for further also. Now I will show you actual site photo, which we have done the construction, and now it is being working out. And we are what's the actual we are getting that we can say power output. All the things has been measured out. That lithium ion battery is being used, and estimated charge time is 4.5 peak hours. So now, because the shadow also came, and at sunrise also we didn't get the maximum efficiency. At mid of the 11 to 12, it starts charging out and gives the that gives us the power generation. This is the monthly average power which we get from we have measured from January to December. And furthermore, we have decided that instead of going to the system, we should do the wireless connectivity communication with that system. So we decided to introduce in our system, in our model, IoT, Internet of Things. So in this, we have decided to take out the ESP32 controller, although we can use other modules also, like we can say Intel NUC board, Nano PIM4, or Intel NU Raspberry Pi, but we decided to use ESP232 controller because it is inbuilt Wi-Fi, integrated Wi-Fi and Bluetooth, as well as it is used in industrialization also, that it can rise temperature. It can work in that temperature also, -40 degree to 125 degree, and it has advanced calibration circuits. So this helps us to make that project efficient and give us the maximum output which we want to be in that. Although we have done encoding in Arduino IDE1, or we have used current sensor for current measurement, voltage sensor, relay. About relay, we have used single channel 5 DC volt relay input of 220 volt AC switching. and as well as use to display also if you want to see
Hello?
physically what's the currently. Hello.
Am I audible?
Yes, sir.
Please come to your result.
Okay, sir. So this is the result. If we talk about the result, in third, actual we have started the reading out from 3rd October 2022. At that first time only we have got the 404.368 watt. And sir, peak what we have got is 423.81 on 3rd of November. Till 4th March 2023 we have worked on, and last date also we have got 379.51. So this is the actual. This page is content of 5 to 6 days, 5 to 6 pages, and we have almost run about 5 to 6 months result via IoT.
Okay, please conclude.
So as about the solar, our solar tree, so it is very sustainable power generation. As it required limited land for that, because it does not, as we know, sir, in panel arrays, solar panel arrays, it required large amount of land, but it required only limited amount of land. It helps in the future project also, like in electric vehicle charging. If you want to charge the electric vehicle, it can be help as a power generator, power to get the vehicle charge, as well as to get the shed for the car, so that it doesn't heat and get the proper shed for that. And we've decided that in the future also we will be working on the charging stations also, because it will providing the electric automobile for the charging, as well as so it is used for it is good for the environment also. It doesn't harm for the environment also, as thermal plants and hydropower that may impact on the pollution or that. As you know, thermal power is not a plant is not being established right now, but also we are depending on that, but it is quite efficient, and it may get more maintenance, but it is more efficiently. And if we work on this, each and every person can have this solar tree on their home. And as well as if we see, we can work on grid system also, that we can produce power and sell it to government also, so that we can have some revenue, as well as government can fulfill the demand of the others. Thank you.
Hello. Yes.
Yes, sir.
Acha, here you are considering the multiple solar panel on a tree. You are just, so what is the average efficiency of your system?
Sir, approx 300 to 400. Sir, not different. Sir, first of all, first we have ordered the 5 solar panels. So, and that 5 solar panel was Excite one. Then again, we want to order the Excite one only. So, but the problem was that that the dealer didn't have, who cannot fulfill our need, because it was out of stock. We decided to take from other manufacturers. So, this is the reason we have to take. This is the reason the fluctuation has been in. If you see in MATLAB also, we have done this to verify that we will be getting a proper output or not. So there's manufacturer called, although 50 watt is there.
Thank you. Thank you.
Welcome.
Thank you, sir.
Up next, we will have paper ID 515, reduction of the degraded power by novel geometric reconfiguration of solar arrays under partial shading conditions by Vijay Lakshmi Mishra. Would you please share your screen and you take the beginning?
So, is my screen visible to all?
Yes, yes.
Okay. So a very warm good afternoon to one and all present here. Myself, Vijay Lakshmi Mishra, research scholar from KNIT Sultanpur. And currently I am at my thesis submission stage, which probably I will submit by next month. Before I begin my presentation, I deliver my deep vote of thanks to RDCPAE 2023, organized by Amity University, who has given me a platform to organize, to present my paper titled Reduction of Degraded Power by Novel Geometrical Reconfiguration of Solar Arrays under Partial Shading Conditions. So these are the table of contents, which is describing as to what all things I am going to describe in my PPT further.
Yeah.
So this is the introduction. As you all know, renewable source of energy is finding wide expansion in today's scenario. Out of this, solar energy is gaining more expansion because it is widely available and it does not lead to any kind of pollution. But what happens is when kind of shadow, please pardon. So when partial shading condition arises, what happens is that the array do not generate that amount of power which it generates under healthy condition. The shading, the kinds of shading.
Excuse me, Rishabh, could you please turn off your mic? Oh, the host, can you please turn off Rishabh's mic? I think you have the authority to turn it off.
नहीं मुझे क्या पता मैं तो बुलाया था मैम ने
तो क्या नौकरी वोकरी को भी देंगे?
नौकरी वोकरी कुछ नहीं है
तो फिर काय को ले लेते?
अरे वो जानते होंगे मैम जानते होंगे मैम ने बोला था
So shall I continue?
Yes. It is noise is coming from your side.
No, mine is totally noiseless. Actually, it's an interruption from your side, sir. So that's what I was. So there are two kinds of shadings, right? Which is classified as static shading or dynamic shading. When I talk about static shading, it is because of the stationary objects, like shown in this figure, like trees, adjacent panels, or the trees that are installed.
We are getting the disturbance from the Rishabh Kumar side. Rishabh Kumar, please mute yourself.
And under dynamic, when I talk about, it is due to the snow or the bird droppings or the dust, right? So when partial shading condition occurs, what happens that under this condition, the array which was capable of generating this blue line indicates that it is generating full amount of power when it is having total illumination. But under partial shading, the power gets reduced, which is shown by the red dotted lines. Because of this, multiple peak occurs on the solar array and it leads to various losses. So taking this in a novel configuration has been proposed in this paper, which is called as geometrical reconfiguration. And for this, I have taken a single diode model. And these are the various specifications of the module in my work. Then the configuration, which is called as total cross-tied connection, I have taken. In this work, I have taken total 81 modules that are connected in series parallel arrangement called as total cross-tied, which is shown in figure 6. And then a more advanced version called as Sudoku reconfiguration I have taken. And on the game puzzle based reconfiguration, all the 81 panels are arranged in row column fashion in that no row or column should have any repeated number of digits. These are the steps which is being used while reconfiguring the solar 9x9 using this technique, Sudoku method. Okay. So this is my proposed novel geometrical reconfiguration. What has happened under this? I have taken 81 solar modules which are arranged in row column fashion. And when partial shading condition arises, what happens? These solar modules gets rearranged in a manner such that the shade gets totally dispersed on the entire solar array, and it is capable of generating the maximum power during that particular case of shading, right? So these are the rules, certain steps which I have opted for the solar reconfiguration method, which is represented in figure 10. Like all the modules are rearranged, and as the shading arises, it gets the geometrical names which are formed, that can be kite shape, square shape, or any rhombus, triangle, what those mathematical shapes we studied during our school days in geometry, right? So these are the kinds of shading patterns that I have tested on my proposed novel geometrical reconfiguration. And these are the various performance metrics on which I have claimed I have worked, that testing these parameters on my novel proposed configuration and then comparing it with the existing one, how my work is more superior than the existing ones in the literature, right? Which is global power, degraded power, fill factor, performance enhancement ratio, right? There are so many in the literature, but these 4 novel and the most recent one I have taken in my study. Yeah. Moving on to the main portion of the work, that is results and discussion. So figure 12 is representing total cross-tied connection output of power voltage and current voltage. This blue line indicates that, and when it has no shading, it is totally delivering 405 watt power. Okay, one module is rated to 5 watt, and we are having 81 such modules, and 81 multiplied by 5 gives us 405 watt power, right? When shading occurs, the power shading 1 S1, shading 2 S2, then these the power which was earlier 405, it gets reduced to this much level, roundabout ranging between 100 watt to 300 watt, and multiple peaks are formed. These multiple peaks are localizing the power. Same which I obtained for the Sudoku reconfiguration and then for the novel geometrical reconfiguration. This I will tell more clearly with the help of the quantitative outcome. So this is the quantitative outcome of my work. You can see that under shading 1, this TCT is giving 211 3.35 watt power. Who is given 206?
Vijay,
But yeah.
please conclude your work.
Yes, sure. Just in a while. This work is just showing what work I did is in a figure plots, then fill factor and power enhancement. Then these are the total outcomes of the result, the comparative outcome of the total work, tabular form, quantifiable form, like challenges can be revised, are used. It further, this can be lead to like testing it on analysis. And the conclusion is the novel proposed geometrical reconfiguration gives amount of degraded power and it in more production. And these are the list mostly comprising of my publications during my research. So yes, this is all for my presentation. Thank you. If there are any questions, I'm happy to answer.
Okay, so here you are considering different topologies, but
yes,
the
sir.
solar using the all the industries only using the series parallel combination. So how your work justify, or how you will correlate your work with the industrial application? Because
so the thing
the
is
industry only using the series parallel, but here you are suggesting honeycomb and TCT. So different model. How you will justify your work with the industry?
Yeah, sure. I would like to answer this. When I'm considering my work from perspective of industry, then I should know the need of my industry. Like when I started working on this 9x9 model, I had studied the topological factors residing in that area. I studied as to what all structures, what all predefined shadings are there. And let me be very clear that this novel proposed geometrical reconfiguration is a static based reconfiguration model, which is based on a one-time reconfiguration. I have studied the topological factors there, and based on that, I have reconfigured the model. And once I have installed that model there, it will be there for lifetime. Nobody can remove that. Okay. So the main ideology behind this is that one should know the topological factors where they are going to install the solar panel. So, right?
Yes. Chalo.
Okay. Thank you so much, sir.
Next, we have paper ID 498, an integrated vehicle damage assessment and repair cost prediction systems using deep learning by Anne Bailey.
Sir, I'm unable to.
Sir, have you received our PPTs? Shall we share our screen?
Yes, you have to share.
Yes, go ahead and share your screen, please.
Good afternoon, dear dignitaries. We thank you for giving us an opportunity to present our paper and work in the RDCPAE conference organized by MIT University. Myself and my co-author, Mr. Abhinav Thomas, we would be presenting an integrated vehicle damage assessment and repair cost prediction system using deep learning. Over to you, Abhinav.
Thanks, ma'am. So I hope I'm audible.
Yes, Abhinav, you are.
Yes, okay. Good afternoon, dignitaries. So I'll start with the introduction to the project. So there is a need for research in assessing vehicle damage through images in the insurance sector, like in the automotive sector. So if we consider the automotive sector, there are multiple divisions in the automotive sector, like spare parts, repairs, and insurance. So when we consider these sectors, we can understand that there is a need for a proper system, like a system that employs artificial intelligence within it, so that the efficiency of these processes are much higher. Like right now, if a vehicle is damaged, it is first towed to a garage. Then from there, the people have to analyze it, and the quotation for the price of repairs only assigned at that time. So it takes manpower and it takes a lot of cost and time for the same. So if you're able to employ it using artificial intelligence, and bring in more innovation into it, we might be able to decrease the price, like cost and manpower and time associated with it. So the goal of our project or research is to create a model that is capable of understanding damage, like analyzing the damage and predicting the cost of the damage. So some of the these are some of the related works. So we have gone through them, and two of them were using
Your result section.
We'll skip related works and we'll go on to the results, sir. We'll even just talk a bit about the data set which we used.
Okay. Okay. So the data set we have used, we have actually created our own data set. We have downloaded images from the internet and we have scraped images from the internet. There are two kinds of data set. One is using a tool known as VGG annotator. Using this tool, we have marked the damages in the data. Like we have uploaded the images, we mark the damage and give an annotation like damaged area to that image. And we have sourced another data from the internet using web scraping techniques. And these images are divided into different folders like minor, moderate, and severely damaged. And another set of folders are front, rear, and side are the regions of collision. And I'll just move on. So the proposed model is using a forced convolution fully convolutional neural network. So in this model, we have encoding layers, decoding layers, and then bottleneck layers. Encoding layers capture the low-level features like edges and boundaries in the images, like textures, color intensity, etc. of the damage. and the high level features are captured by the bottleneck layer, which in turn captures factors such as shapes and structures like structure of the car, contextual information, and spatial arrangement, like if it is in a car, where in which part of the car that damage actually is, and gradual transitions, like there may be a transition of intensity of the pixels, so it will be also be tracked using the bottleneck layer. And moving on, we have trained two other models using sequential convolutional neural network. These models are used for image classification. These classify the loaded images into minor damage, like the severity of damage and the area of damage. So here in this image, we can see that when we loaded this image into the model, it has predicted the class as only a minor damage. And here in the second image is the second model, and it predicts as a damage from the front.
Time is over. Time is over. Please conclude. Directly
Okay.
come to your conclusion.
Okay, sir. Okay, sir.
Okay. Yes. So the result of our analysis is that we have been able to create all of the above mentioned models, and a model is able to predict the price and mark the region where the damage is actually present. Yes, that's actually. I'm open to questions. Hi, sir.
Thank you. Any question, sir? Okay, all right. Thank you.
Thank you, sirs.
Yes. Now that all the speakers have concluded, I would like to formally ask for permission to end the session. Sir? Thank you so much, Sir and Nine, for being here today and spending your time with us. It is now time to bring the session to a close, and I would like to give our most heartfelt thanks to our esteemed guests for being here today. Their insight is incredibly invaluable, and we're extremely grateful they decided to spend their time with us today. Thank you to all the faculty members of the Electrical and Electronics Department for organizing this event, plus students like us to get the opportunity to learn from experts in the field. And thank you to all the volunteers for ensuring this event runs smoothly. Thank you. You can leave the meeting now. IT support, could you please close the meeting? Thank you.